And this question has 4 parts, part A, B, C, and D. And we are going to do one part at a time. So let's look at part A. It says, given that P equals 2, Q equals 0, and R equals -3, calculate first R to the power P plus R to the power Q, and then part 2 we have to calculate P squared minus R squared. So let's first look at part 1. R to the P plus R to the Q is equal to R we see is -3 and P is 2, so this is -3 squared plus R again -3 to the power Q. Q is 0. Now -3 squared means -3 multiplied by -3, so that's going to be a +9, because a negative number multiplied by a negative number is positive. And then -3 to the power 0 is going to be equal to 1, because any number raised to the power 0 is equal to 1. Alright, so this is going to be equal to 9 plus this is going to be 1, and our answer therefore is 10, and that's the answer for part 1. Now part 2 is P squared minus R squared, and P squared minus R squared simply is going to be 2 squared, because P is 2 minus R squared, and R is -3. So 2 squared is going to be 4 minus -3 squared, just like here, is going to be 9. So that is 4 minus 9, which is -5. 4 minus 9 is -5. So that's part A. Now part B says we are to write algebraic expressions for the following. 1. Twice the sum of the squares of x and y. Twice the sum of the squares of x and y. And then in part 2 we have to do the product of 2 consecutive odd numbers where the larger number is x. So let's look at the first one. Twice the sum of the squares of x and y. So the sum of the squares of x and y is going to be x squared plus y squared, and then we are taking twice that, so it's 2 times x squared plus y squared. Right, so if we put that in, that is what we get. That's the answer for the first part. Now for the second part, it is saying that the product of 2 consecutive odd numbers when the larger number is x. We have to write an algebraic expression for that. Now let's talk about odd numbers a bit and look at the properties of odd numbers. An odd number is an integer that is not divisible by 2, or we can say it is not evenly divisible by 2. And it's an integer. Remember, integers now are positive and negative whole numbers. So the set of odd numbers is going to be this. And if you look at the trend, if you look at this section, we have -5, then -3, then -1, then 1, then 3, then 5. Right? So we are familiar with these as odd numbers, 1, 3, and 5. For example, these are the common ones, all the way up, and then 7 and 9 and 11 all the way up. Alright? Well, this is the set of odd numbers, and we notice 0 is not there. 0 is not an odd number. Right? 0 in fact is an even number. Make that point here. Right? Note that 0 is not an odd number. 0 is an even number. So we're just putting that in for information. Now if we also observe, we see that the difference between the odd numbers is 2. It goes up by 2. Just that they are the numbers that are not evenly divisible by 2. Right? So that's our next observation, that the difference between consecutive odd numbers is 2. Right? Note also that the difference between 2 consecutive odd numbers is 2, and therefore if we have 2 consecutive odd numbers as we have here, and the larger one is x, then the one before that must be x minus 2, right? Because they go up by 2. and we say if x is the second, the larger of two consecutive odd numbers, then the first one, the smaller one, must be x minus 2, because the difference between odd numbers is 2, right? And based on that, the product of those two consecutive odd numbers, where the larger one is x, is going to be that x minus 2, that's a smaller one, multiplied by x, which is a larger one, which is equivalent to x multiplied by x minus 2. So that's the answer for that second part. Alright, now let's move over to part C. Now for part C, it says solve the pair of simultaneous equations x plus y equals 7 and xy equals 12. Now if we observe, x plus y equals 7 is a linear equation. In other words, it will produce a line on a graph. But xy equals 12 is going to be a curve on a graph. So this really is a situation where we have a line and a curve. Now because this is a situation where we have a line and a curve, we can expect that we might end up with more than 1 point of intersection. And normally at the CXC level, you are given questions where there are 2 points of intersection, and that is what is happening in this case. But let's go ahead and see how we solve this question. Now normally when you have a line and a curve simultaneous equation, you normally do it by substitution. Remember, simultaneous equations can be solved using elimination method, the method of elimination, where we eliminate a variable, or we can use substitution. And normally for equations where one is linear and one is not linear, we tend to use substitution, and we tend to substitute the equation of the line into the equation of the curve. Alright, so that's what we normally do. So in this case, this is the line and this is a curve. Alright, so let's go through this question. So we are given the line, and the line, what we'll do is make y the subject. Alright, we make y the subject of the equation of the line, so y is going to be equal to 7 minus x. All we do is subtract x from both sides of this equation, becomes y equals 7 minus x, and we are calling this one equation 1. And then xy equals 12 is now equation 2. Now what we're going to do, we're going to be substituting the equation of the line into the equation of the curve. We're going to be substituting for y. So in the equation of a curve, we're going to replace the y with 7 minus x, and that's how we substitute. Alright, so we're going to end up with this. What we are saying is that substituting E1, which is equation 1, into E2, that's equation 2, we're going to end up with x multiplied by 7 minus x, that is where the y was, 7 minus x, equals to 12, equals to 12. So all we need to do now is solve this equation for x, because this equation now has one unknown in it, and any equation with one unknown can be solved. Alright, so we need to expand this and see what it comes out to be. Now when we expand this side, we end up with 7x minus x squared equals 12. That's 7x minus x squared equals 12. Now this is basically a quadratic equation. It is not yet in the standard form of a quadratic equation. So what we need to do is rearrange it such that it goes into the standard form of a quadratic equation, where you have the quadratic expression being equal to 0. Then we can apply one of the methods of solving a quadratic equation to do it. And the reason we know that this is basically a quadratic equation, basically not yet exact, is that the highest power of the x, of the unknown variable, is a x squared. It has an x term in it, and it has a constant term in it, and it can be transposed into the standard form of a quadratic equation. Alright, so let's move ahead and try to transform it. Alright, so we're going to put the x squared term in front, and we must carry the sign. So the negative x squared goes to the front here, and then we have a plus 7x, and then this 12, we subtract the 12 from both sides, or you simply say we take the 12 over this side and change the sign. So subtracting 12 from both sides become negative 12, and we have 0 left on the right hand side. So now it's looking more like the standard quadratic equation. But what we're going to do, we're going to make it a little bit more user friendly in terms of how we solve it. And what we're going to do is make the coefficient of the x squared term positive, and to do that we simply multiply the equation by a negative 1. When you multiply an equation by a constant, you multiply each term in the equation by that constant. Alright, so that is what we're going to do next. So when we multiply by negative 1, the negative x squared becomes an x squared, the plus 7x becomes negative 7x, and the negative 12 becomes positive 12, and the 0 remains 0, because negative 1 multiplied by 0 is still 0. Now we are going to factorize this. We are not going to go through the process of factorizing here, because this question is not really testing our ability to factorize. Our ability to factorize will be tested in this question. So here we will go through the whole process of factorization, but here we're just simply going to factorize it. And when we factorize this expression, we are solving the quadratic equation by the process of factorizing, or by the method of factorization. When we factorize, we end up with x minus 3 times x minus 4 equals 0, and we can check that this factorization is correct, because x multiplied by x is x squared, negative 3 multiplied by negative 4 is the positive 12 out here, and then the middle term here is a combination of the far product and the near product. So that is x times negative 4 is negative 4x, and then negative 3x. So negative 4x and negative 3x gives us negative 7x. So we know that this was factorized correctly. Now if x minus 3 multiplied by x minus 4 is equal to 0, when two numbers multiply together is equal to 0, one of them must be 0, one or the other must be 0. So we know that either x minus 3 equals 0 or x minus 4 is equal to 0. Alright, so we can put that down. So you see, x minus 3 is equal to 0 or x minus 4 is equal to 0. So if x minus 3 is equal to 0, then x is equal to 3, and if x minus 4 is equal to 0, then x is equal to 4. So those are the two x values that we are gonna get: x equals 3, x equals 4. So these are the two x values, the two values of x where the line and the curve intersect each other. When you solve simultaneous equations, basically you're trying to find where the two equations intersect. In this case, it's a line and a curve, so solving them simultaneously is finding the points where the line and the curve intersect each other, where the line and the curve occur simultaneously together. Alright, so that's what we're saying, that's what we're doing. We're trying to find the points of intersection. Alright, so now that we have found the x values where the line and the curve intersect, we need to find the corresponding y values. Right, and you can substitute in either the equation of the line or the equation of the curve, and you normally use the one that will give you the answer much quicker. And in this case, we have y as the subject of E1, and if we know the x value, then we can find out what the y value is. So it's best that we use E1. Alright, so what we are gonna do, we are gonna say substituting in E1, which is y equals 7 minus x. Alright, and then we're gonna look at these individually. Okay, so we're gonna say at the point where x is equal to 3, y is equal to 7 minus 3, because it's 7 minus x, so y is equal to 7 minus 3, which is equal to 4. So that point of intersection is 3, 4. X coordinate, y coordinate, 3, 4. So that's the first point of intersection. And then the second one is going to be at x equals 4 now, that's this one. At x equals 4, y is equal to 7 minus 4, because we're looking at, again, 7 minus x. So in this case, the x is 4, so 7 minus 4 equals 3. So the line and the curve also intersect each other at 4, 3. X value is 4, y value is 3. So these are the 2 points of intersection of the line and the curve. And so we have solved them simultaneously, and the solution is, that's our solution line. The solution line is 3, 4 is one point of intersection, 4, 3 is the second point of intersection, and that's our solution. Okay, now to part D. Part D says factorize completely. Now this is very important. Completely, meaning you factorize all the way down till you cannot factorize anymore. That's what completely means. So sometimes there are 2 or even 3 steps in the factorization. Alright? But the word completely means that you cannot just do the first step. You have to go all the way. Alright? So the first one we're going to be factorizing is 8m squared minus 2. The second one is 3px minus 6py minus qx plus 2qy. And then the third one is 3x squared minus 7x minus 10. This is a quadratic. Alright, so there are 3 different types of factorization covered here in this question. In fact, 4. In this one, the negative here is indicating to me that there's a difference of 2 squares, and there's a m squared here. So I know that somewhere in this is a difference of 2 squares. That's one of the methods of factorization that we are required to know for our CXC exam. And in this one, as I see the 4 terms, I know that this one more than likely is a factorization by parts. In fact, it is a factorization by parts. And then this one clearly is a quadratic. Right? And there are different methods for factorizing each one. So let's look at the first one. Now the first one is 8m squared minus 2. Now firstly, the only common factor initially is 2. The common factor in 8m squared and 2 is 2. So how you factorize by the 2 is that you divide this by 2. If you divide this by 2, it becomes 4m squared, and if you divide 2 by 2, it becomes 1. So the first step in this factorization is this. But this now can be expressed as the difference of 2 squares, because 4 is a perfect square of 2, m is a perfect square, and what we must remember is that 1 is a perfect square. 1 is a perfect square of 1. Okay, so we cannot forget that, and we cannot lose sight of that. So we actually have the difference of 2 squares inside this bracket here. So what we're going to do is express it as a difference of 2 squares. So this 2 is this 2 here, and then this 4m squared, we write it as 2m all squared, because 2 squared is 4 and m squared is m squared here. So this now is 2m squared, and as we said, 1 is the same as 1 squared. So there's our difference of 2 squares. And then if we apply the rule of the difference of 2 squares, then we end up with this 2 is this, then this 2m squared minus 1 squared becomes 2m minus 1 multiplied by 2m plus 1. And there we have factorized it completely. This was one first step of factorization, but the question said completely, so we had to look for again more levels of factorization, and there it was, the difference of 2 squares was right inside here. Okay, so that's the answer for the first part. Now the second part, as I said, is looking like a factorization by parts question. So that is what we were given. Okay, so that is what we were given. Now when you do a factorization by parts, what you do, you look for a common factor in the first 2 terms, and then you look for a common factor in the second 2 terms, and you factorize it in such a way that one factor that you end up with from the first 2 terms also exists in the second 2 terms. So let's go ahead. So the common factor in the first 2 terms is going to be 3p, because 3p can be divided out of this, and 3p can be divided out of this. So 3p is going to be the common factor of the first 2 terms, and then in here the common factor is going to be a q, but it's going to have to be a negative q, because we're going to end up with a negative here. Let's have a look at it. We must factorize it in such a way that we end up having common factors on both sides, so we can do another level of factorization. So as I said, 3p is a common factor in the first part, so if we divide 3p out of this, we end up with x, and if we divide 3p out of 6py, we end up with 2y, because 3 times 2 is 6. P is here, and then the y remains. Okay, so this is what we get when you factorize the first two. And then now, because we want a x minus 2y to appear here as well, what we realize that what we have to factorize out is a negative q. We have to factorize a negative q from these two, such that we end up with an x in front. Just as we have an x in front in the bracket here, we have to factorize a negative q. And then when we divide this positive 2q by negative q, it becomes negative 2y. And then we can check the expansion, because negative q times x is negative qx, and negative q multiplied by negative 2y is positive, because negative multiplied by a negative is giving us back a positive here. So this factorization is correct. And what we see now is that we have a common factor now here in x minus 2y, x minus 2y. So it is 3p x minus 2y minus q x minus 2y. So the common factor now is x minus 2y. Right? So when we factorize that, we end up with 3p minus q times x minus 2y, and that's our factorization for the second part, and it has been done completely. Cannot be factorized any further. Okay, so let's now look at the factorization of the quadratic expression here. This quadratic expression, we're going to look at the method that we use to factorize the quadratic expression. Alright, now for reference, we're going to say let y be equal to 3x squared minus 7x minus 10. Okay, that is just for ease of reference. Now when we are factorizing a quadratic expression, right, it has only 3 terms in it, and the aim really is to create a situation where we can factorize by parts. So the method is to split this middle term here, and the method to do that is a straightforward method. The first step is to multiply the end coefficients. So the end coefficients in this case would be 3 and a negative 10. Now remember, you must carry the sign. It's very important that you carry the sign. So let me show you what the first step is. So the first step is going to be 3 multiplied by a negative 10. Those are the two end coefficients, and that result is negative 30. What we are doing now is that we are looking for factors of this negative 30 here that will add to the middle term, which is negative 7. That's what we are doing here. And if we cannot identify those factors of negative 30 that adds to negative 7 right away, we do it step by step. And I'm going to just show you what we would do if we were doing it step by step. So see, we are searching for factors of negative 30 that adds to negative 7. Now because we are searching for factors of negative 30, we know that one of those factors will have to be negative, right? And since the result of the summation that we want is a negative number, we know that the larger of the two factors is going to be the negative one, because when you add them, you're going to end up with a negative number. So the larger factor is going to be negative. So what we did, we said, okay, let's try 1 and negative 30 first. 1 and negative 30 are factors of negative 30. And when you add 1 to negative 30, you get negative 29, which is not negative 7. So these are not the factors that we want. So we'll move down the line and we'll say, okay, 2 and what? 2 and negative 15. 2 times negative 15 is negative 30. So 2 and negative 15 are factors of negative 30. But when you add them, you get negative 13. So no, that's not it. We want negative 7. So we move down. So we go 3 and what? 3 and a negative 10. 3 and negative 10 are factors of negative 30. And when you add 3 to negative 10, you get negative 7. So yes, we are going to split this negative 7x into 3x minus 10x, right? So the factors we are looking for are 3 and negative 10. So we can go ahead and put that, right? That's it. 3 and the negative 10 are the factors we are looking for now. Alright, so we can move that now out the way and move to the next line. So what happens now is that y is equal to 3x squared, and we're splitting this negative 7x into 3x minus 10x. The 3 and the negative 10 is what we use to split this negative 7x. See, 3x minus 10x is still negative 7x, and then this negative 10 comes back here. And what we have done, we have created a situation where we now can factorize by parts. We can look at the first two, factorize it, then look at the second two, factorize it, and we're going to end up with a common factor. So the common factor in the first two is going to be 3x, and the common factor in the second two is going to be negative 10, and we must have the same thing in the brackets. Alright, so we have y equals, the common factor in this part is 3x, so 3x squared divided by 3x leaves us with x, and 3x divided by 3x leaves us with 1. So inside the bracket here now is x plus 1, and then because we know we want to have x plus 1 in the bracket over here as well, right, we know we have to factorize a negative 10 out of this x here. So negative 10 goes here, the x plus 1 now goes in the bracket, because negative 10 multiplied by positive 1 gives us negative 10. Alright, so that's the factorization of the second part, that's the factorization of the first part. This is the factorization of the first two, this is the factorization of the second two, and then x plus 1 now becomes a common factor. So it's 3x times x plus 1 minus 10 times x plus 1. So it's just like saying 3x apples minus 10 apples equals 3x minus 10 apples. Right, so we end up with this: y equals 3x minus 10 apples, and apples we said is x plus 1. So that's our factorization. So that's the method of factorization. So thanks for watching this question. Hope you learned a lot, and we look forward to presenting other questions for you later. Alright, bye.